Hello, everybody, and welcome to our air navigation course. This is the first lecture where we will address the term air navigation. Air navigation is a subfield of aerospace engineering where we care about how to steer an aircraft from one initial to another final point. This mission, given by our origin and our destination, is what we attempt to address in air navigation. We can have an individual or a network perspective of the problem. From an individual point of view, we will basically address two questions. First one is the determination of position. Where is the aircraft, or where am I if I were the pilot of the aircraft? This is named position awareness, knowing where you are at a given time. In order to address this, we will look at the different techniques that are used today. And also, air navigation addresses the problem of the network as a whole. If you're aware that today in airspaces such as the European, the amount of flights is such that it can be congested, and we will not only have to care about how to address a flight efficiently and safely from one initial point to another final destination, but we will have to care about this problem escalated 1,000 times and how the interaction of the trajectories poses threats to safety and efficiency. Good. We may also wonder in this small introduction to air navigation about the similarities and the differences with other transport modes. What can make air navigation different from other transport modes? Well, let's think about a few facts. First one is we do not need ground infrastructure, or better said, we do only need ground infrastructure at our origin and at our destination, our origin airport and our destination airport. But in the middle between these couple of cities, we just need air to fly. We do not need roads, we do not need railways. This imposes a tremendous amount of freedom to air navigation because basically our three-dimensional movement can be directed in any direction we want. Well, we will see later that regulators and different problems impose restrictions to the airspace that we can use, but initially, if we were completely free, we would not have to rely on any previous creation of ground infrastructure. We just need ground infrastructure at our origin and at our destination, and this is a tremendous advantage for air navigation in terms of efficiency when compared to other transport modes that care a lot about surrounding mountains, avoiding cities, etc., etc. All right? Good. Second difference we may find is that here fuel imposes important limitations. If we run out of fuel during our flight, chances are we'll have to glide onto an unprepared terrain, and chances of an accident are quite high. This is not the case in other transport modes, where the lack of energy will just cause the vehicle to stop and wait for someone to help. Here, this cannot be permitted. We cannot run out of fuel in the middle of the flight. And this means that the determination of position awareness is of extreme importance because we cannot waste any time getting lost. Once people get lost, normally they fly in circles or they just try to find a way. Here, if we do that, we are just wasting fuel that might be of extreme importance. So the third difference we find is that here we don't have any chance to stop and ask about our position or stop and ask about directions. Pilots, if they have radio communication with air traffic controllers, they can ask for instructions through the radio. But here, if we get lost and we run out of fuel, we have no way to stop and ask anybody in the middle of the air about how to get to where we want to go. Fourth difference we've noted down here is that the mean through which we move, which is the air, strongly affects our trajectory and particularly, basically, the atmosphere. Because of the presence of winds, some trajectories might be more efficient than others because of the presence of some meteorological phenomena such as cumulonimbus or the presence of fog or even volcanic ashes may make some paths safer than others. Aircraft speed is really high, forcing pilots to make decisions in real time pretty fast. The faster the decisions are made, the higher the likelihood to make errors. So here we have to set things up in a way that they are straightforward, in a way that they are as simple as we can, because we don't want anybody to have forgetfulnesses or make dismissals or make errors in the end. But not everything is different. Few things are similar with other means of transportation, and we can think of the danger of hitting other vehicles, having accidents with other vehicles, mirror collisions, for instance, or hitting the ground, hitting obstacles. Um, be aware that the two most likely events that can down an aircraft are onboard fire and mirror collision. So mirror collision is something we obviously want to avoid, and we will see through our lectures how we have deployed different means to avoid these kind of situations. Also, it can happen that because of a loss of position awareness, because of not knowing where we are, we may end up flying against an obstacle, a mountain, or just the ground. And these kind of accidents that normally happen in the night or in the middle of a fog are named CFIT accidents. CFIT stands for Controlled Flight into Terrain.